Hi, thanks for having me here. I'm talking about writing your own Java profile in 240 lines of pure Java code. But before we start, I want to start with a small story. It was, you probably remember it, a few years ago, the Corona times, where people couldn't meet in large audiences for conferences. So I was organizing conferences with a couple of friends in Karlsruhe, where I come from, where like professors can present their knowledge to the common public. And it was Corona, so we wanted to make it more interactive, and we wanted to have an application where people could just answer questions like, how old is the universe, and give an estimate, and we can then later find a winner and send them some gift. And I was the computer science student there, and they asked me like, hey, Johannes, aren't you a computer scientist? And I'm like, yes. They are like, could you write us a web app? And I'm like, yes, that's the reason why I tried to do a PhD for 2.5 years, to write small, simple web applications. And of course, as you all know, from your fellow PhD students, they know how web development works. So I felt like, we have a client here, we have an admin interface. The client regularly just asks the server, hey, are there any questions? If yes, I present them. And then the server stores it somewhere. I thought like a database is overblown. Nobody needs a database. I only have like 90 people accessing the web page. And so I was like, yeah, I store it just everything in a JSON file. The file system keeps track of all the things. And that won't be a problem, because I'm like, with Donald Knuth, premature optimization is the root of all evil. And I'm like, yes! I remember this well. I developed a simple solution, and then the event came. Any guesses what happened? It crashed, of course. The server was overwhelmed. And so the thing was, we were filming this in a central location with just a couple of skeleton people, so with just a couple of people sitting there and recording. And I was constantly restarting the server, so it dropped all the connections so the people could use it again. It was quite embarrassing because I mistook like the quote of Donald Knuth, because his full quote is, we should forget about small efficiencies, say about 97% of the time. Premature optimization is the root of all evil. Yet we should not pass up our critical opportunities in that critical 3%. A good programmer will not be lulled into complacency by such reasoning. He will be wise to look carefully at the critical code, but only after it had been identified. So essentially I was mistakenly only taking like the short quote of this, and so I'm like, how can I do this? How can I find the problematic places? Here comes Profile to the rescue. So yay, that's what the talk is about, Profile and how you write your own. When I talk to people that I know that aren't computer scientists, some of them are, they work on cool other stuff. I tell them I'm doing profiles. They're like, are you someone like Sherlock Holmes solving crime scenes? Or as I'm in the Netherlands, are you someone like Van der Valk, who does cool crime scene investigation, shines light on like the bloodstains and looks who the murder is? In my case, I know who the murder is, me, because I looked into Git blame and I was the only one contributing. So Git blame is a good thing to know afterwards who was the murder and how to blame. But in the end, so I use the profile and I run with it, run a stress test on it to see what the problem was. One common visualization in profiling is the flame graph. So it shows you the proportion of method's runtime compared to the runtime of its caller. So here on the top we have the basic method. It's like pseudocode to make it more easier to understand. And on the bottom you see a bar representing the runtime. So main method took all the time, and what does the main method do? It does some setups, finding a server port, whatever. And then calls the server loop method. And what does the server loop do? It essentially loops over all requests, gets a new request, and we're only caring about like the client request because we only have one admin user, so this doesn't matter. So essentially most of the time the server loop calls 100 question requests. And then what does 100 question request does, it asks like, hey, is that question enabled? And if yes, emit the current question, and if not, emit like an empty thing. And that is like asked by the client like every like 10 seconds or so. And any guesses where current question and is question enabled spend most of the time in? Any guesses? Louder. Yes. Yes, it was like it was parsing JSON all the time, and that's great because that's the reason why it crashed, and it was embarrassing. And if you don't believe me, that's a real issue I have with. I can later give you the link to the GitHub repository where have the flamegraph that was almost the same, and it was quite embarrassing. But hey, flamegraphs are great. I love flamegraphs. When you do something stupid, it punches you in your face, and it's impossible not to see it, according to Mario Fusco. And I can agree. We can all see that it's not a good idea to store all data in JSON and parse it all the time. So then I replaced it with something simple, with a simple SQLite database, and it works. The problem is now Corona is over, so we don't need this application anymore. But okay, I think it has also good things that Corona is over. And then what you see is that you can that profiling should be part of your toolbox. So here we use debugging, we use stress testing, and then we use profiling to shine light on this whole thing. So I think profiling is something that you should have in your toolbox of techniques. You should really look into profiling tools and not just do this when your boss, like at 3 a.m. in the morning, tells you like, our application is crashing, please fix it. And you're like, okay, I'm reading the manual for JDK Mission Control or other tools, and that's probably too late. So I'll show you more in the later part of the talk which real tools there are. So I'm Johannes Bechberger. I'm giving this talk here. I sometimes talk about profilers, as you see there. That was me in QCon London this year. I work at the Submachine team. We're one of the biggest contributors to the OpenJDK. The Submachine is an OpenJDK distribution like Corretto and others. And we developed such things as the new null pointer exceptions that give you like the course or more, and one person on our team is the JDK 17's updates maintainer. So if you're still using JDK 17, you should switch to JDK 21 then. He's the guy who keeps all the nice bug fixes from JDK 21 coming into JDK 17. If you want some of these stickers of our great submachine, I have a couple of them here in the front. Just come later and I'll give you one. If you want to know more, there's a QR code there where you can learn more about our cool thing. We are a team at SAP, and SAP has many, many, many more great open source projects. But that's all from me now. The funny thing is, approximately half a year ago, I also did my first presentation in the Netherlands. It was at the J-Driven Full Stack conference. It was kind of on the same topic, so I'm happy to be again here in this area, and now on with my talk. When I'm not giving talks, I'm usually working on profiler front ends, I'm working on profiles itself, and I'm also working on my own JDK enhancement proposal to make profiler writing easier. But now to the questions that I ask you. Who of you used the profiler? Hands up. That's a lot. It gets larger every time I do this talk. Maybe it's because I'm giving this talk, or maybe performance gets more important. I don't know. Causality and like the other thing. So in JetBrains survey in 2022, like 2/3 were also yes, and that's a great thing for profile writers because it means people already use our stuff. But what is profiling for those 3 in the audience or so who didn't use it? According to the vulnerable Hackers Dictionary, a profile is a report on the amounts of time spent in each routine of a program used to find and tune away the hotspots in it. So that's essentially what we were doing in the beginning. We were checking how much time every method took and saw, okay, parse JSON is probably a hotspot, so we get rid of it and everything works fine. Regarding profiles, there are 2 different main types. They are, for one, instrumenting profiles, and the other main type are sampling profiles. Instrumenting profiles are quite basic. So you know when you have, for example, the server loop method, and you would want to know how much time it took, what you normally would do, you you get the time at the beginning on the method, and then print the duration at the end of the method, and you then know, okay, the server loop method took n milliseconds, n seconds. And that's fine. The problem is you don't want to do this manually. So the idea with instrumenting profiles is you log the entry and the exit of every method, or of every method that you're interested in, and then print it out and then post-process it to get flame graphs or so. This is quite cool because you see every invocation of every method that you're interested in. The main problem is, and you do this automatically, so you insert these automatically, but the main problem is your profile code isn't your code that you're running in production, because you're inserting new instructions there. Your just-in-time compiler doesn't like it. It might have other memory characteristics, so you essentially uh, you're essentially getting worse results, less accurate results. And then people came to the idea that maybe it's enough if you sample. So if you ask the JVM regularly, like every 10 to 20 milliseconds, hey, what are you currently executing? What's on your stack currently? And this gets us an approximate picture, but that's usually enough because we only need like the large hotspots. We don't care usually about methods that only took like 1 millisecond. And the cool thing here is the profile code is equal to the production code. We're not modifying the code. So it's usually far better, it's far more realistic, and that's the approach that therefore most of the profiles use these days, because it's just the state of the art. And you might have guessed that profiles are like these large tools. They're like machine learning black boxes, and only the experts work on it, like me, but you can also work on profiles. It's quite easy. So profiles aren't rocket science. And I thought this, and I'm like, what's the easiest way to tell people, to show people this so they can comprehend? I'm like, I can write my own. And it was quite funny because I wrote a blog post on it, and then someone posted it on Hacker News, and then people knew how to do this. So it's quite funny. You can read the blog post there. And essentially the idea is we write now a functioning profile that emits flame graphs in around 240 lines of Java code. But first, before I show you a bit of the code, first the structure. So what we do is we write a Java agent. So the idea is we have a program that runs alongside your Java application in the same JVM in a separate thread that you can attach and deattach. And then this main method that handles all the option parsing starts our profile in a new thread. And what this profile does, it samples, so it asks the JVM what are you currently doing, then it sleeps, then it samples, and it sleeps all the time. So essentially we get a sample every 10 to 20 milliseconds. And then of course we have to do something with the data, because data is nice, but if you can't visualize it, data is essentially worthless. So the idea is we store this data in a database, in a small data structure, and I call it store, and this produces you then with the help of some other libraries a flame graph. But don't run out of this room, I lied to you. It's not 204 lines. That was before I fixed a few of the bugs. Because of course I put it came on Hacker News, and then people were like, but you have there a small bug, there, and then I also thought like, maybe it's good if I download the JavaScript and CSS resources down to my own machine so it works in live demos when I have time for them. So that all in all makes it to 251 lines of code. I hope you aren't disappointed. You can find the code online, and it's MIT licensed, so just go with it. A funny thing is, when you do open source, you never know where it happens to end up. So I was giving this talk in May in Milan, in Italy, and then someone came to me and was like, "Oh, I want to use this in production," and I'm like, "Okay." And he was like, yeah, he works as a consultant at a bank, and they don't like him attaching profiles at runtime, but he needs to profile. So he said to me like, hey, I'm just embedding it into my application. So because it's just Java code, you can embed it and then run it alongside. And I'm like, okay, I can't do anything against it because it's MIT licensed. Feel free, but yes, so they are existing profiles, and please use them. But still, if you have this need, go on the internet, you find it. I have a list of literature later, so yeah. With regarding now the implementation, because I showed you like, hey, that's how it in theory works, you sample and everything, but how does it really work down to the code? And the thing is, the code is so short I can just show you. So the main method, the idea here is that we pass our profile as a Java agent. So I call the tiny profile because it's tiny, and you pass it some agent args. And the idea is here that we can attach this profile either at the startup, as we do here, like pass it via -Java agent, or later via, for example, J command. And this results in two different main methods. That's just when you want to write an agent, sometimes you have you have an agent main called when you attach it later, and the pre-main when you attach it at the beginning. And the cool thing is we then just start our profiling thread. But when we do this, so the problem is concurrency comes in our way, so it's quite difficult to get it right, but the idea is essentially that we create a new instance, and this instance is then a thread, and then later we just start it. And the idea is that we then have some options that we parsed before, and we add an interval option. We have a flame path option where we store the flame graph, and then a print method table option where it tells you, hey, please also print like how much time did each method waste. And then we started, and it's a daemon because stopping this, your whole application shouldn't be delayed by like the profiler still running. And the thing is, like, all this option parsing isn't really important. I just asked ChatGPT to write it, and it worked. And that's a good application for this because that's quite repetitive. It worked, and I didn't have to write it because the problem is not that many people write these Java agents, so they aren't any dedicated option parser libraries. So you have to write it by hand anyway. So yeah. The profiler, what it does, I said it before, it samples and sleeps and so on. We first create it, and when we first create it, we attach a shutdown hook. So the idea is with a shutdown hook, that's a runnable or thread that's called when the JVM shuts down, and the idea for us is here that we use this to print out the flame graphs or the other information and shut down our profiler thread gracefully. And now the idea is with sampling. So sleeping is quite well understood. For sleeping, we just use like thread to sleep. But for sample, the major idea in many profiles is like we sample only a subset of the threads, because sampling all threads can be a bit hairy because there are usually many threads. The problem is, how do we get in pure Java the list of all the threads currently available? We only get this by like asking the thread class get all stack traces, and then we have already all stack traces, so we can use them. And essentially, we get all stack traces. Stack traces are things that you get with like exceptions, and use them later. And essentially, what we're checking, we're only adding the stack traces of threads that aren't our profiling thread, because usually we are not interested in the performance of our profiler, because profiling your profiler is kind of pointless. It happens, I did this also before, like with my C++ based profilers, but it just blows your mind because, yeah, it's like debugging a debugger, which I did before. It's funny. It's like the red pill and the blue pill, and you don't know which to take. So essentially, what you probably all know, like the stack trace that you see when you have an uncalled Java exception, and essentially it contains all the information that we need. We see, for example, where it was, what the current method is that is currently executing, that's currently on the stack, which file name, which line number, and that's enough to use as information. And then we come to the store, and the store essentially takes all these samples, so all these stack traces, and combines them down into a simpler data format, which it then uses to create these flame graphs. Because flame graphs would be great, it's like one of the most common ways to visualize this information. This flame graphs were invented by Brendan Eck, who's a really great person in the profiling space. And his most famous video, when you want to look it up, is man shouting in data center at hard drives. Because he had a new visualization, he wrote a new visualization and for a tool that detected latencies in like these hard drives. In the olden times, these spinning things, and the thing was, when he was shouting at a hard drive, the latency was increased of every access, so you could see him shouting and the latency spiking. So it's just a funny little video with like 1 million or so views on YouTube. So if you want to see a Chrome man shout at hard drives, go for it. I once, when I gave this talk the first time, I had it in my slides, but the problem is like audio is not great from this machine, so I don't have it here. But essentially, we use flame graphs, and what we see is that whenever we have this flame graph, we definitely know that, for example, there must be a sample which contained the main method that called the server loop, that currently is calling the handle question request, that calling the count question, and that's calling parse.json. And so the idea is now we have such a sample, what do we do with it? We got it in and we create a tree because computer scientists like trees. They're easy, they are fast to store because essentially we throw all the timing information, so all the information on when it happened away, when a sample happened away, so we can reduce it to a simple tree. So here we have a main node for the main method. It occurred once in our samples because that's our first sample. Then it has a child server loop, it has a child handle question request, it has a child count question, and a child parse.json. Then we get another sample, and it's like the same. We see, okay, we already have a main node. This main node already has a server loop and so on, so we increment this value. And then we have a different sample where the top is missing, and so we do the same again. Here's a bit more interesting because we have on the top is question enabled and parse.json, and as you see, we branch out, and we can do this all the time, but in this example we're bored now, and we want to try to get back to flame graphs. And it's quite easy. We know, for example, that the most time a method took was like 4 time slots, and so we divide our bar by 4, and then we build it up. As you see, it's just essentially a different visualization of our tree. The important thing here is timing versus hit. So we know here that, for example, the parse.json method on top was hit like 2 times. That doesn't mean that it's like run for 2 for 2 intervals. We only know that it ran twice when we like sampled. So there's a distinction between like sample count and runtime. It's usually comparable, but it's not the same. So just keep this in mind because we're sampling. It's just an approximation of like the duration. And now with the power of D3 flame graph, we can create flame graphs, and they work, and you can like click around in them. And if we have later some time, I can show you in the demo. But in reality, usually you don't use this because it, of course, has problems. It's not as fast, and it has a safe from bias and everything. But in reality, we're using sampling profiles, and there are 2 different kinds. So they are internal and they're built-in and external sampling profiles. That means like external means like we attach it from outside to the JVM. Built-in means it's built into your JVM. With the external ones, you have synchronous and asynchronous ones. So the synchronous asks the JVM, hey, can you give me the stack trace when you're ready, when you're in a safe state? Because the JVM regularly has safe states where it like checks things for garbage collection and so on. And we can use these, and they are asynchronous profiles, and they just ask the JVM, give me it now. And I don't care if you sometimes crash. I'm working on it so that it doesn't crash anymore. It crashed more, but it might crash every few million years. If this is a concern to you, don't use async ones. And with the synchronous ones, they are quite popular because Visual VM, that's like in many polls, one of the most used open source profiles, is based on these synchronous approaches. It was also built into NetBeans, and it's there since 2010 and like open sourced quite early, so many people use it. There are also like, for the older people in my audience, there's the For the Analyzer. It started in like 1991 by Sun, and in 2003 they wanted to add the capability to also analyze Java, and so they added the async get call trace API method to the JVM, then removed it 3 months later. from the official header, but now it's there. You can use it by using DL Open for the C geeks here. It's quite good. It might disappear anytime, but it's still there. And then like in 2007, people started using it for their own open source profiles. And nowadays, Async Profile uses it, or in the last version, it doesn't use it anymore, but similar techniques and similar crude APIs. And I'm working on making it better. So my job is around making this asynchronous, getting asynchronous stack traces far better, far safer, but I'm 2 years in and still working on it. So hopefully the next time I come here, I have a job that makes everything better, but I don't expect it. So there are also built-in ones. Essentially, that's specific to the OpenJDK. So async, get call trace, and the things, they might also work on OpenJ9 and other JVMs, but the built-in ones is specific to the OpenJDK. And there's the Java or later JDK flight recorder. And that's the idea that runs beside, that is built in your JVM, can use all the nice internal features. And this has a front end called JDK Mission Control. The problem was it was like developed by JRocket like 2006 or so, and then later bought by Oracle. But it was only like open sourced in 2018, so before that it cost a lot of money, so many people didn't use it. But nowadays you can freely use it, and many of the profiling tools that you currently use, like the application performance monitors from Elasticsearch, from Grafana, so they use a combination of like async profiler and the JFR data. But take the profiles with a grain of salt, please. The thing is that there aren't that many tests in the OpenJDK and also in OpenJ9 on the underlying APIs. They have some subtle bugs sometimes, so please keep in mind that while profiles are great, there are no magic tools that tell you where something is wrong. It's really hard to write profiles that give you totally precise information, and they usually, especially in like the top methods with inlining and everything your JIT does, it's hard to be really precise. So just keep this in mind. Usually your profiler is correct, but there might be times where it's only approximate, especially when you're using sampling profiles that are approximate after all. But how do you know? Obtain a profile? Yes, you could use like the tiny profile that I showed you before. But if you want to obtain a real profile by a real profiler, you can use Async Profiler. I'll be presenting JFR and Async Profiler and following. With Async Profiler, you just you just add it via agent. It's written in C++, and tell it to start. Then you tell it which basis the sample should be. So should the intervals be based on the CPU or time or ball clock time and so on. And you also tell it where to output it. And the cool thing is you can also tell it, hey, please use the information from the built-in profiling to get even more information out of it. And if you want to know more, there's the Async Profiler manual with examples by Krzysztof Sluzarski. I'll link to it later in my literature. So there's a large document where Krzysztof tells you a lot about how to use Async Profile, and it's one of the most complete guides out there for any profile that I found, for any open source one. And then there's also JDK Flight Recorder. The main advantage here is that it also works on Windows. So Async Profile doesn't have Windows support. Yes, JetBrains has like support in IntelliJ for Windows, but I heard that it's crude. I heard through the grapevine that they're doing lots of magic tricks to facilitate it. But essentially, JDK Flight Recorder is the only major profile that also works on Windows. And how you use it is quite simple. In modern Java versions, you just tell the JVM, please start a flight recording, and here's the file. And the thing is, these JFR files are like the common denominator of many of the profiling tools, because this file is so commonly used there. And in other versions, you had to tell, so please use flight recorder, please enable this. And then you have to do something that Async Profile does automatically, but you have to tell, so please add more debug information in. This doesn't have like a huge performance impact, but it improves your accuracy, especially when you have like longer running loops dramatically. So just use it this way. And of course, you can attach async profiler and JK flight recorder also at runtime. For example, here you use jcommand. Jcommand is like one of these little known utilities with which you can do lots of things. For example, here you can start JFR and stop it. And the cool thing about JFR is not only does it run with Windows, which is really important to me running on a Mac and having a Linux machine at home, but it also supports lots of events. So there are so many events, I thought like I want to know more about these events. I wanted to see what the events are, and they're distributed in the OpenJK source code. So I wrote a web page called the JFR events a collection where you can see all the events, see in which Java version they appear first, and even see some examples and see that there isn't that much description out there. So if you want to contribute descriptions to these events, please do. I try to convince my colleagues that they do, so slowly they're coming more and more descriptions. So this is a way to explore all the JFR events that you get, and the events, for example, for the GZ phase pauses, so how much time it took for every GZ phase, or for the decompilation statistics, or for everything that a true JVM nerds likes to know about. And for example, here there's things about compiler inlining just because it's cool. If you ever wanted to know which inlining stuff your compiler does, here you get. Of course, the more events you enable, the more expensive it gets. And then everyone takes it usually at conference about their new SaaS stuff, about their new software as a service. And consider here we have our new service called Math as a service, where we compute Fibonacci numbers. We compute it with the best algorithms that ChatGPT could come up with when we tell it to write the worst algorithm, but that's fine because we're just burning investor money. What we want to do, we want to use these in many cases these custom events, because JFR allows you to create custom events that are also present in your JFR file and that you can use with your regular JFR viewers. And the cool thing is, it's quite easy. You just create, in our case, a class session event that extends the JK to JFR event, and then we store a session ID and an end Fibonacci number that created, and we just have a constructor, nothing more. And what JFR gives us then is a nice API. We create our event, and then we tell it to begin, so we associate it with like a stack trace and also with start date, and then also we do our computation, and then we commit it down to the JFR file, and we can then view it in our favorite JFR viewer and just see that the 37th Fibonacci number took like 17 milliseconds. And that's quite cool because we don't have to scour through additional logging files. We just have it in our actual profiling file, which I can really recommend because this helps, especially when this data is profiling adjacent. And as you've seen, we were inspecting profiles just there. So there are, of course, multiple ways to inspect it. One is, of course, the simple flame graphs that I've showed you in the beginning, but there are also UI tools. For one, the most commonly used in the open source world is the JDK mission control. This is an Eclipse-based application that tells you lots of information, and it has a steep learning curve, so you might want to take a few hours to try to learn it. But then if you know how to work with it, it's really powerful. It gives you some basic information, and also it gives you information on the method profiling, so it gives you information on the flame graphs, and more. But the thing is, its usability could be better, and so last year in August I was like, there should be an easier way. Just want to right-click on the method, tell it to profile, and then it should show me a nice flame graph, and I'm fine. And was like to my boss, can I work on this in August? And he's like, fine. Everyone is on vacation anyway, so do as you like. And I'm like, yes. And so I created the first open source profiling plugin for IntelliJ. You can find it online. It's like openly licensed out there. It's the Java JFR profile plugin. Just install it and give it a try. and please contribute to it. So I'm always happy to see new contributors and to see new bug fixes in there, because of course I'm nowadays doing other things than just working on profile plugins. So what you can do with this plugin, you can right click on the main method, tell it, so hey, please profile this application either with JFR or with async profiler, and then it gives you these trees that we before used to create the flame graphs. You can also see this tree here visualized. And the cool thing is, I didn't write this UI myself. I'm standing on the shoulder of giants. I'm standing on the shoulder of Firefox, because Firefox has a nice profiler, and I helped to extend it and work on this too. And you can even do things like click on it and see each line here and how many samples there are for every line, which is quite neat. And you can also see flame graphs and more information, and also view events. So you could please give it a try and give me some feedback. I would be happy for it. It's open source, so please do it with every open source project you use. If you like it, consider contributing, either by posting an issue or by creating a pull request if you like. Or even if you can't do this, please spread a word about it. So you might ask, so there's no free lunch, so what's the impact on the performance of these profiling tools? It depends on the settings. So it depends on the settings, on the number of threads, and many more, but usually it's between like 0 and 5%. In literature, people tell you that it's like lower than 2%. It really depends on your application. And the thing is, you have to consider that it creates profiling files that might be quite large. So what I would recommend, to get a feel of it, use the profiling first in like a demo application and get a feel of it, how large it is, how much of the information that's in the profile you actually need. So do you need only the method profiles? Then it's fine, because that's quite cheap. Or do you need all the garbage collection information? And it depends on what you want to do. So one of my colleagues works on garbage collectors, so he helps customers fix problems with garbage collection, and he uses all the GC information all the time, but you probably won't in your day-to-day work. And I usually would recommend async profiler with JFR sync or async profiler alone, because it's like the best solution in the open source world that we currently have out there. Now to my last part, because people usually ask me after conference, but what's about continuous profiling? So profiling in production all the time. And one of the easiest ways to just use async profile and tell it, please create a new JFR file every like minute. It's essentially like a bash file where you say, oh, create profile for 1 minute, profile for 1 minute, and so on. That's quite easy, and you can view it, especially if you have like an outage. You can then get the JFR file for this time slice. But there are also more modern tools, like for example Pyroscope, that use tools like async profile under the hood, but then present it to you in a quite nice UI where you can see all the frame graphs and such, and it automatically streams it to a server. And there are of course other solutions by vendors that don't open source this stuff. So just take a look around, because there are lots more, and they're coming to the conference near you, probably in a couple of years. Because what I found, like in the last 10 years, the field of profiling got more and more important, because of course when you're optimizing your applications, you're also optimizing the amount of money that you need to run your application, or the amount of users that you can deal with, and that's becoming important more and more. So I think it's good for you as a software developer to add this skill to your toolbox of skills, this profiling, alongside your debugging skills, which you should probably improve, because you can always learn more about this, your testing skills, and more. And if you want to know more, I'm part-time nerd on Twitter, and you find me on mostly_nerdless.de, where I post a blog post every week or two on profiling and debugging topics. You find my team at Sweet Submachine. You can find stickers here in front, so please take a view. And please rate my talk in the JFall app. And if you want to know more about this talk and about all the literature I talked about, just go to this QR code. It shows you to a dedicated page where I collected all the information and also collected a list of interesting talks on YouTube that you can listen if you want to go really in depth. And thank you. Do we have time for questions? I don't know. Yes.
How could you integrate this in your CI/CD pipeline?
Oh yeah. So there are possibilities. There's Gunnar Morling, who wrote the JFR unit where you can write tests based on JFR data. So you can write a test that tells you, oh, I'm executing this code while running JFR, and you assert then, oh, it took like that much time or de-optimize these methods or so. So there's JFR unit by Gunnar Molling. I can really recommend. It's a nice toolkit. And I can recommend his blog. He wrote a lot of things about profiling. Anything else? Okay. It's too bright out here, so it's funny because there's a light, so I don't see half of the audience. I hope you're still there in the back. So if you have any more questions, I'm still around the whole conference, so just come up to me, ask me about profiling or debugging or OpenJDK, because I'm a Java developer that does C++ all the day, so probably one of the only one in the audience who only does like C++ development, but still calls himself a Java developer. It's quite confusing when I'm next apply for a job and I'm like a Java developer with 4 years of C++ experience, but whatever. So have a nice time at the conference. Thanks again for JFall for having me here. It was a really great pleasure, and have a nice time. Enjoy all the other talks, and see you sometime.